Uh, Today we are going to study the commutation technique. As we know, the thyristor is a current control device. So once it is on, it cannot be turned off unless until the current flowing through this is less than the holding current. Right? So we have to do some mechanism so the current flowing through this is less than the holding current. For that we have a certain commutation techniques. The first one is a class A commutation. It is known as load commutation. You can notice that by the virtue of load, the current flowing through this thyristor T is less than the holding current, so it get turned off. Right, when load resistance R is low, then we connect capacitor C in series with this, and when R is high, then capacitor C has to be connected in parallel with load resistance R. The main requirement for successful commutation of the thyristor is that the circuit must be under damped, right? And only for DC this load commutation is used, not for AC, because in case of AC there is a resonance current, means the nature of current is in the oscillatory in nature, right? So as the supply is DC, so current has the tendency to decay to zero by its, I mean it's natural, right? Under steady state current is zero, so because of this the current flowing through the thyristor T is less than the holding current and thyristor get commutated, right? This commutation is also known as self commutation or resonant commutation, right? So the current is like this. The current is like this. So here thyristor get automatically get turned off. Right? Now the next commutation technique is class B commutation, which is also known as resonant pulse commutation. We have already discussed this technique in class, but since I am recording the lecture, so I have covered all the 6 techniques, right? Here you can see the main thyristor is T1 and the auxiliary thyristor is TA, along with resonant component L and C are there, that you can see. The direction of capacitor current the is shown, as well as capacitor voltage is shown. That means left hand side plate is positive, right hand side plate is negative, right? So capacitor is charged up to voltage Vs and there is no current. The moment we trigger the thyristor T1 at t equal to 0, the load current, which we have assumed that constant, right? Constant load current I0 start to flow. Constant load current start to flow through thyristor T1, and at instant T1 we trigger thyristor TA. The moment we trigger the thyristor TA, as capacitor left hand side plate is positive, right hand side plate is negative, so a resonant current established through capacitor C, thyristor TA, and coming back to the inductor, then capacitor C. So that you can see here, this IC current, this current is flowing for the duration of pi, right? During this duration, capacitor right hand side plate become positive and left hand side plate become negative. Clear? So at instant T2, at instant T2, thyristor TA get turned off because the current flowing through this is less than the holding current. Now this current, that the capacitor current, where the capacitor voltage is minus Vs, it is further flow through the inductor L, then diode D, and through thyristor T1, and then come back to C, that is the capacitor C. One can think in the direction that how it is possible that current in the thyristor T1 flowing from cathode to anode. Actually, it is like that anode to cathode current is I0, and since this capacitor current is flowing in reverse direction, so anode to cathode current is keep on decreasing, which you can see here, let me highlight this it is decreasing, and capacitor current is increasing in positive sense. Now at instant T3, the capacitor current IC is equal to I naught, so thyristor T1 get commutated. Now the capacitor C has to be charged up to plus Vs as the initial condition, so it is charged through a constant load current I0, which flows from supply to capacitor, then inductor, then diode, and then load, which you can see is from instant T3 to instant T5. The capacitor is charged through a constant load current I0. Capacitor is charged through a constant load current I0 and it is charged up to plus Vs. Right? One thing you can notice that the capacitor is in reverse bias. Up to instant T3 to, let me correct this instant is up to this point. This is your instant T4. Right? This instant is T4. Let me erase this. Just a moment. Let me erase this. It is not here. It is at this point. Let me just give me a second. Done. This instant is TC. Alright, so it is T4. This instant is T4. Alright, so up to T4 this capacitor is having voltage less than 0. That means in negative direction. So during this period, thyristor T1 is subjected to reverse bias. So this is the circuit turn off time TC. You cannot turn on the thyristor T1 unless until it is in reverse bias. So after instant T4, you may get turn on again. Alright. So this is how this class B commutation operate, and the value of capacitor current is given by minus Vs under root C by L sin omega 0 t, which you can say it is minus Ip sin omega 0 t, where Ip is peak value of the current. Capacitor voltage is simply, it is the integration of this capacitor current IC 1 by C integration IC dt, which is come out to be Vs cos omega 0 t. So for successful commutation, the peak value of the capacitor current must be greater than the load current. Right? This commutation is called current commutation, class B commutation, or the resonant pulse commutation, right? So main thyristor turn off when the current flowing through this is equal to I0. Here you can see, all right? So you can figure it out how much time it will take to turn off after initializing the process. T3 minus T2 is the time when current start decaying from I0 to 0, and pi is the time where which is required to flow this resonant current. So total time is pi plus T3 minus T2, right? So this is the time which is required. Now you have to find out the one problem related to this. In the circuit shown above, the supply voltage is 230 volt, capacitor is 20 microfarad, inductor is 5 microhenry, initial voltage across C is 230 volt, I0, that is the load current, is 300 ampere. Now you have to calculate the conduction time for the auxiliary thyristor TA. Next, voltage across the main thyristor when it gets commutated, and the next, the circuit turn off time for main thyristor. These three things you have to find. You have to find yourself. I will discuss these things, I mean this problem, when I take on offline class after joining my EL, right? So meanwhile you can try at your end. I am skipping this for now. Now next commutation technique is class C commutation, which is known as the complementary commutation. The circuit for this is shown here. The first one circuit where you can see there are two thyristor T1 and T2. These two thyristor T1 and T2 are operate in complementary fashion. Means once you want to turn off thyristor T1, you have to trigger thyristor T2, and when you want to trigger turn off thyristor T2, you have to trigger thyristor T1, right? And you can see the moment you trigger thyristor T1, the current flowing through the thyristor is the ones that is the I1 is the current which take the path from supply to resistance R1, that is Vs by R1, and another current flowing through that thyristor T1 is through resistance R2 and C, which is shown as IC in pink color. So total current flowing through the thyristor T1 is I1 plus IC. You can notice here we have triggered the thyristor T1. The moment you trigger, the two current flowing through thyristor is Vs by R1 and Vs by R2, because at the initial point capacitor act as a short when it is uncharged. So at t equal to 0, the current flowing is Vs by R1 plus Vs by R2. After that, the load current Vs by R1 is flowing through thyristor T1. Once you trigger, at the same time you must notice that the thyristor voltage of that second thyristor VT2 is the same as the capacitor voltage VC. So capacitor voltage is charged from 0 to Vs, then it will remain Vs as a unless until you will turn on the thyristor T2. Once you turn on the thyristor T2, the capacitor, which is having right hand side plate positive, left hand side plate negative, the whole voltage applied through the on the thyristor T1. So thyristor T1 is subjected to reverse bias voltage Vs, and its load current is shifted from T1 to T2. Its load current is shifted from T1 to T2. So T2 starts conducting. So T2 starts conducting, and the current flowing through this is Vs by R2. And you must notice now the capacitor current. Now capacitor left hand side plate is negative, right hand side plate is positive. So the total voltage is 2 Vs through the circuit R1, C and thyristor T2. So at at the instant when you trigger thyristor T2, capacitor will get charge in opposite direction. That means left hand side plate positive, right hand side plate negative, with the initial current 2 Vs by R1, 2 Vs by R1, which you can notice here, 2 Vs by R1, 2 Vs by R1, right, upon R2, and exponential decay would be there, that is minus 2 Vs by R1 e to the power minus t by R1 C. So current is flowing in this fashion, and the capacitor is charged from plus Vs to minus Vs. Capacitor is charged from plus Vs to minus Vs, and your thyristor T2 will conduct with initial value of the current Vs by 2 R1 plus Vs by R2 to decaying up to Vs by R2, right? So in this way it will go like this. The capacitor current IC, which you can notice that at instant T1, thyristor T1 get turned off and T2 get on, and the capacitor current is flowing in reverse direction with the expression 2 Vs by R1 e to the power minus t by R1C, and it is 0 at T2. So at T2, capacitor voltage is charged up to minus Vs, and now there is no current through resistance R1 and capacitor C. The only current flowing through thyristor T2 is Vs by R2. The same process repeated itself. One thing you must notice that during the very first cycle, the thyristor current IT1 is equal to Vs by R1 plus Vs by R2, whereas in subsequent turning on, it is Vs by R1 plus 2 Vs by R2. The reason is same, because the capacitor is charged. At the initial condition, capacitor was uncharged, but after subsequent cycle, the capacitor is charged. So the total voltage in the capacitive circuit is twice Vs, right? So in this type of commutation, thyristor is commutated by transferring its load current to another thyristor, right? Now T1 would be turned off at T1, so T2 is to be turned on at T1. The moment thyristor T2 is on, voltage across it is 0. VT1 is minus Vs, as the capacitor is charged up to minus Vs, right? So IC is equal to 2 Vs by R1, and IT2 is equal to Vs upon 2 R1 plus 2 Vs upon R2, as I told you. Now if I apply in the KVL, it would be like this: R1 IC plus 1 by C IC dt is equal to Vs. By taking Laplace and its inverse Laplace, we get the value of current, capacitor current, which is come out to be 2 Vs by R1 e to the power minus t R1C. Similarly, we can have the capacitor voltage by simply integrating the current over a period of time, 1 by C0 to t IC dt plus initial voltage, that is plus Vs. After solving this, we will get Vs is equal to 2 e to the power minus t upon R1C minus 1. Alright. Here one thing you should notice, that t is measured from the instant t1. T is measured from the instant t1. Means from here. Which is quite obvious. Right. So the circuit turn of time for thyristor T1. What is the meaning of circuit turn of time for the thyristor T1? It means you cannot turn on thyristor T1 unless until it is in the forward bias. You can notice thyristor T1 is in reverse bias for the duration of Tc1, So that means Vs, that the capacitor voltage Vc is changing from minus Vs to or you can say the time required for the thyristor T1 voltage from minus Vs to 0 is circuit turn off time Tc1. So it would be given as Vs1 minus e to the power Tc1 by R1C must be equal to 0. So once you calculate this, Tc1 is come out to be R1C ln2. Similarly for thyristor T2, you can notice here it is subjected to reverse bias for the duration of Tc2. So Vs 1 minus e to the power T R2C minus 1 must be equal to 0. So from here you get Tc2 is equal to R2C ln 2. Now based on this you have to solve one numerical problem, that is for class C commutation. Vs is equal to 200 volt, resistance R1 is equal to 10 ohm, resistance R2 is equal to 100 ohm. Number 1, find peak value of current through thyristor T1 and T2. Second, value of C if circuit turn off time is 40 microsecond with factor of safety is 2. Circuit turn off time with factor of safety is 2. Right? So that you have to figure it out. Clear? Now next commutation technique is class D commutation. It is also known as impulse commutation. Here you can see that the initial capacitor is uncharged. Right? So the moment we want to use this circuit, we have to charge the capacitor such that its upper plate positive, lower plate negative. We have to do some arrangement such that its upper plate positive, lower plate negative. So initially you can see that at t equal to 0, capacitor is charged up to voltage Vc equal to Vs with upper plate positive, lower plate negative. Now the moment you trigger thyristor T1, a resonant current start flowing through thyristor T1, then inductor L, then diode D, and come back to the capacitor. And capacitor lower plate become positive and upper plate become negative. Right? Lower plate become positive and upper plate become negative. So the moment you trigger the thyristor T1, a load current I0 start to flow. The moment you trigger the thyristor T1, load current I0 start to flow. Let me do small correction. This is I0 equal to I0. This is your load. Right? So the moment this thyristor T1 is triggered, load current I0 start to flow. Let me make this I0. Right? And along with this, thyristor T1 is also having a resonant current which is impulsive in nature, means for the half of the cycle, unless until the capacitor lower plate positive and upper plate negative, it will flow through thyristor T1, which you can see. So the current flowing through the thyristor T1 is I0 plus IP, where IP is the peak of this impulse current. and at the end of period pi, capacitor lower plate is positive, upper plate is negative. Now if you trigger the thyristor TA, the entire negative voltage Vs is applied to the thyristor T1. So this get turned off and its current is shifted through through capacitor C, then TA, then load. Capacitor C, then TA, then load. Alright? So it will be like this, and I0 current is flowing like this, and capacitor is charged through a constant load current I0. Capacitor is charged through a constant load current I0. The moment capacitor is charged up to plus Vs, auxiliary thyristor is automatically get turned off. Auxiliary thyristor is also getting turned off, and circuit is commutated, means that there should not be any current. And the capacitor current is given by Vs under root C by L sin omega 0 t. Right? Now based on this, we can also calculate the value of TC1. And TC2. Right? So it is very simple. Pi by 2. TC1 is pi by 2. So you can also see from the figure itself. Now based on this, you can find out the value of this peak current through C, T and TA, that is the capacitor, thyristor T1 and auxiliary thyristor TA, and also find out the circuit turn off time for T1 and TA. If source voltage is 230 volt, inductor L is 20 microhenry and capacitor C is 40 microfarad and load current is 120 ampere. You have to calculate the peak current through capacitor C, thyristor T1 and auxiliary thyristor TA. Right? You have to also calculate the circuit turn off time for thyristor T1 as well as TA. This you have to figure it out. I will discuss when I'll take class in offline mode after 29th of January. Okay, next is class E commutation or external pulse commutation. The circuit for external pulse commutation is shown here. The main thyristor is T1 and there is load. You have to turn off thyristor T1. For that, a commutation circuit, which is an external pulse commutation circuit, you have to generate pulse externally. How you will generate? The moment thyristor T3 is triggered, a resonant current flows through inductor L and capacitor C, and capacitor C is charged up to twice V1, where V1 is the supply at right hand side. Right? So once it is charged up to 2V1, the circuit get turned off. Now if you want to trigger the thyristor T1, you just trigger thyristor T2. The moment you trigger thyristor T2, the entire twice V1 voltage is applied to thyristor T1. So thyristor T1 is subjected to reverse bias if Vs minus 2V1 is negative. Subjected to reverse bias if Vs minus, that the prime requirement is that the value of pulse of current obtained from separate voltage source to turn off the conducting thyristor, the value of peak current must be more than the load current, and Vs minus 2V1 must be greater than, Vs minus 2V1 must be negative, so that your thyristor T1 get turned off and your capacitor is get discharged through load. right? So this is your external pulse commutation. This is your external pulse commutation. Now last commutation, which is the class F commutation, which is also known as line commutation. It is for AC circuit. You can notice the load resistance is R. Just for simplicity, I have taken the load is resistive in nature, right? But in actual, it is definitely RL type load, right? RL or RLE, any type of load could be there. So you can notice the moment by the virtue of the supply itself, the current flowing through the thyristor is the less than the holding current. So it is get turned off. It is get turned off. Let me correct this. This is the VT1. VT1. Now voltage across the thyristor is also shown here. Once it is on, there is no voltage drop across the thyristor. Of course, I have neglecting the conduction drop, right? So in short, we can characterize the commutations are, it could be line commutation, which is class F commutation. This type of commutation is used in AC regulator, phase control rectifier, step down, cycloconverter, etc. In upcoming classes, in future units, you will study all these circuit, and where you will find that line commutations are used here, right? As far as load commutation is concerned, it is used in series inverter. For force commutation, it is always for DC choppers, right? DC choppers and inverter means where the supply is DC. The thyristor or the devices never come in the reverse bias unless until forcefully you commutate, and may either shifted the current flowing through this to other device, or the current flowing through this less than the holding current, then only the thyristor get turned off. So BCD commutation are come under the force commutation category, and the last is the external pulse commutation, which is class E commutation. You can note it down the one more numerical based on this. The circuit is shown here, the capacitor is there and the thyristor T1 is the main thyristor, TA is the auxiliary thyristor, right? So you have to find out the value of this. Let me write 5 ohm here as well. 5 ohm, right? So you have to find out the value of circuit turn off time for the circuit shown here, right? The initial capacitor voltage is 230 volt. Supply voltage is 230 volt. Capacitor C is 10 microfarad and resistance R is 5 ohm. You have to find out the value of turn off the circuit turn off time. You have to find out the value of circuit turn off time, that you have to find, right? So with this your commutation techniques ends. With this your commutation techniques end, and I hope you guys will try to understand all this. And once I join the university, you must have doubts, right? You must have doubt, then we will do it once again, right? So bye bye, take care and do study. We will meet very soon. Love you all. Bye bye.